Hi everyone, this is the video for the guided notes of the unit called Transformations of Functions, and this is objective 1. So we are going to fill out, it's 2 slides for these notes. We'll go through both slides together, you filling out along with me. It's a little different because we are going to use a poster, an online poster, and you can find this poster 2 different places. Up here in the corner where it says poster and a bunch of exclamation points, I have linked it so you can click on that and open it up. And let's open it on a new tab. So this is what the poster looks like. You also can find it if you go back to the classroom, it is under objective 1, just right below the notes transformation poster. So if you want to use it on the quiz, which I highly recommend, it's on the classroom as well. So we are going to be talking about 4 different types of transformations. Transformations means you're changing the function, and there's different ways you can change the function. We are going to talk about horizontal transformations, vertical, reflection, and then dilation. If you notice on our poster, those are our 4 main categories: vertical, horizontal, reflection, dilation. And yeah, let's just jump into it. So here's the table. What I'm asking for you in this table is to make equations that represent each of these types of transformations. So the first transformation that we're going to talk about is horizontal, and it's asking what does the equation look like if you were to move the graph right 3? All right, so if you look at our poster under horizontal, there every example on the poster is if you're moving by 2s, we're going to make an equation that's moving by 3s. So doing the same thing, just using number 3 instead of 2. So when you move right 2, look how our equation looks. It's y equals, like always, we have parentheses and we have x minus 2. Now, we're going to be talking only about quadratics, which are parabolas, so that's why everything's going to be squared. But notice the main thing I want you to see is how does the transformation right 2 look? It's parentheses x minus 2. So if we're going right 3, it's going to look like, and let me make this font a little bigger so you can see it. It's going to be y equals parentheses x minus 3 squared. Instead of x minus 2, it's going to be x minus 3. Okay, now let's do left 3. On the poster, we're again talking about 2s in the poster. What it looks like when you want to move the graph left 2, y equals, again, parentheses, x plus 2. And if you see, there are pictures showing you what does that look like. So when we want right 2, our graph is moving to the right 2. When we go left 2, our graph is moving to the left 2. So let's make an equation that will instead say left 3, right? So it's going to start with y equals parentheses x plus 3. So if you notice, whenever you're moving right and left, you're going to be using parentheses. And it's kind of the opposite. If you're moving left, you want to usually put a minus sign, but you're going to put a plus sign. And then same thing with the right, you're going to be using a minus sign and a plus sign. Okay. Next is what about vertical? What if we're talking about up and down? So I want to make an equation that says up by 3. My poster, I'm going to look at vertical. How does the equation look like? Remember, we're using 2s in the poster. There are no parentheses if you notice. It's just y equals x squared. And then at the end, there's a plus 2. That means up 2. So if I'm going to go up by 3, it's going to be y equals x squared. Whoops. Plus 3. Up by 3. Okay, what about down by 3? Maybe you already guessed it. It's going to be y equals x squared and then minus 3, which our poster shows. What if you're going down by 2? It's a minus 2. Okay. Next, the last 2, these ones, the first 2, horizontal, vertical, are pretty, I don't say straightforward, but you're really either using parentheses or not. Reflections and dilations get a little bit weirder, but what a reflection is, and hopefully you've taken geometry and at least heard the word reflection, but reflections, if you notice on our poster, it's when it gets flipped. Either it gets flipped up and down or it gets flipped left and right, okay? So if you're flipping over the x-axis, you're going to be flipping it down. It's going to be flipping down, okay? There's no numbers involved here. It's just straight what axis you're flipping it over. So y, a reflection over the x-axis is y equals negative x squared. Notice that negative out front, that makes everything negative and it flips down. So that's going to be the same here, y equals negative x squared. Now, if you're reflecting over the y-axis, so left and right, it's still a negative out front, but it's inside of parentheses. So it would just look like y equals parentheses x squared, negative x squared, sorry, parentheses. Okay? Last type of transformation is called dilations, where you could either be compressing it and it's getting wider, or you could be stretching it out and it's getting skinnier. So let's look at compression first. So when you're compressing something, the only thing that you're doing to the equation is you're putting either a fraction or a decimal out front. A fraction or decimal tells your graph that it's going to be getting wider. So if I'm compressing by 2, look what I do. I put it into a fraction. I put it under 1 over 2. So if I'm compressing by 3, I'm going to put it into a fraction 1 over 3 squared. And then next, if you're stretching it, so like if I'm stretching by 2, you just put a 2 out front. Just a whole number, 2 out front. If I'm stretching by 3, it's just going to be a 3 out front. So that was super quick, but your equations will always have these different forms for every transformations. You're just changing the number. So if it was right by 7, you would just do x minus 7. You know, if it was left by 10, you would just do x plus 10. So the equations are always going to look the same. It's just however you're moving is the number you're changing. So let's try this out by answering these 2 questions. And these are the type of questions that you're going to see on the quiz. So first, it's saying, which of these following transformations will shift the function down 2 units and vertically compress it by a factor of 4? So now we're putting multiple transformations together. So if you see I highlighted the 2 different things, let's just focus on one at a time, okay? So the first thing that this transformation is saying is it's going to go down by 2. Well, on my poster, down by 2, remember, is just a minus 2 at the end. No parentheses, nothing fancy, just a minus 2. So when I look here, I want to see, okay, which equations have minus 2 at the end? I know that A has a minus 2 at the end. I can see it. B is a plus 2, so that's definitely out. C has a minus 2 at the end, so that's a potential answer of mine. And then D, the minus 2 is actually in parentheses, which means left or right. So that is not my answer. Okay, so it's either A or C. Next, it has to also be compressing by a factor of 4. Okay, if we go back and find compress, remember, compress has to be a fraction or decimal. So, you know, when it was 2, it was 1 over 2. If it is 4, it should be what? 1 over 4. The letter A would actually be a stretch because the 4 is not a fraction out front. So I'm going to leave C highlighted. That is my answer. This equation says down to compressed by a factor of 4. Okay. Next one, which of the following transformations will transform f of x by shifting it 3 units to the left? So let's just stop right there. Actually, we can go up to my little chart. What does 3 to the left look like? It looks like y equals parentheses x plus 3. So it's x plus 3 in parentheses. I can see already that B is actually the only one that has x plus 3, right? Everything else is either x minus 3 or it doesn't even use the number 3. And then just double check myself. The second part says that it has to be stretched. Well, I know that number 2 out front, remember, means stretched. Okay, so again, you will have questions like this on the quiz. Just pick out the different transformations, use your poster, use your table, and kind of the process of elimination to figure out what's your answer. All right, slide 2. Another type of question that you will see is not words, but I'll give you a graph and you have to figure out what is the transformation just by looking at the graph. Okay. What I will say, and this is very important, so make sure you listen to my next part here. You always want to start with the graph that's at 0. So in these two examples, that is the red graph, it is at 0. Okay. And then figure out how did it transform to the blue graph. If you start at the blue graph and go to the red graph, everything's going to be the opposite. So always start whatever graph is at 0, that is the graph you're starting with. So looking at this example 1 here, my red graph at 0, if I wanted to move to the blue, I have to figure out how did it transform? Well, I definitely see that it went down. It went down 1, 2, right? Went down 2. That's an obvious one. Something else that happened, it got flipped, right? And remember, whenever a graph flips, that's called a reflection. And when it's flipped upside down, it's over the x-axis. So I'm looking for whatever answer says down 2 and reflection over the x-axis. So if I go through here, this is right 2, this says up 2, this says stretch by 2. Here we have a translation reflected over the x-axis and shifted down 2. That is the one I want. Okay. Last one. Here we go again. Another picture. Remember, we're always starting at 0. That's my red graph, and then we're going to the blue. So, a couple of things that I noticed, and if you want to look, I would always look at, the point that's at 0, and then how did it move to the center point of the blue? You don't want to look at a random spot. Keep your spots the same. This middle point here, how did it move to my middle point on the blue? So it definitely went to the right, 1, 2, went to the right 2, and it went down 1. So we have to look at what equation says right 2, down 1. So I know right 2 looks like parentheses x minus 2. So looking through here, it looks like C is the only one that has x minus 2 in parentheses. And then just to double check, I also think it went down 1. Well, this one has a minus 1 at the end. Okay, so this will be what your quiz is over. It could either be giving you words and you're giving me an equation, or giving you graphs and figuring out what the transformation is. So use that poster and good luck.